are you, my friends? We are continuing our Algebra Course Series. This is Lecture 7 that will cover radicals. So, Lecture 7 about radicals in the Algebra Course Series. Now, radical, this is the symbol here. You can see the symbol. The square root here is a symbol. This is a positive square root of the number. This is a positive square root. That's the meaning of this symbol. So when here we have square root of a is equal to b, that means b squared is equal to a. Remember the conditions, a positive and b should be positive. Remember here, this is a big error. Some students, they write square root of 9 plus or minus 3. That's wrong. Square root of 9 is only 3. Square root of 25 is only 5. If you have a minus outside here, then this minus is coming from the minus 1 outside. Now, if you have a negative number under the radical, square root of minus 9, this is not a real number. Because minus 9 here, see this is a, it should be positive number. So there is no real number equals to square root of minus 9. Now let's go in general now. We have nth root of a. You see n here, n is called on the right side here, we call it the index. Please know this word all the time. This is n here, is the index. And a is the under the radical. Remember, under the radical, we call it radicand. These are very important words you have to know in vocabulary. Okay, so nth root of a is equal to b if b to the power n is equal to a. Remember, a is positive and b is positive. Let's see example 1. Cube root of 1000 plus 6th root of 64 divided by 5th root of minus 32 minus 4th root of 16. You can have a few seconds here to evaluate these numbers. I can help you in the first one. Let's see. Cube root of 1000. So this is 10 times 10 times 10. See here, this is the index 3. Here the index is 6. Here the index is 5. Here the index is 4. So if the index is 3, that means we have to have 3 numbers there, 10 cubed. Then this will be equal to 10. Now, 6th root of 64. What number to the power 6 we can have in the 64? So this is 2 to the power 6. Now let's see. The first one, cube root of 1000 equals 10. Why? Because this 10 cubed, this is the index here, is equal 1000. 6th root of 64, 2, because 2 to the power, the index 6 is 64. Now look here, we have 5th root of minus 32. The index here is odd. If the index is odd, the number can be positive, can be negative. I will explain later. If the index here is even, the answer always positive number. So minus 2 to the power 5, you can multiply minus 2 5 times, it will be minus 32. 4th root of 16, 2 to the power 4 is 16, so the answer here is 2. So just write the number, 10 plus 2 over minus 2 minus 2. So the answer will be minus 3 in the whole value of the expression. Now, this is what I'm saying here. If you have the index, if you need to simplify or evaluate nth root of a to the power n, you have two cases actually. You have to look at the index. See the index, it will tell you how the answer will look like. If the index is even or the index is odd, positive integer. So if here is the index is even, that means we have to put absolute value because this radical should be positive. If the index is odd, This n will be 3, 5, 7. Odd number, the answer is a only. Nth root of a to the power n is equal a. A here can be positive, can be negative. Now, why? Some people, they ask why we have to put absolute value here. I will put an example here. For the example, square root of x squared. If you write x, that's false. See, the index here is 2. That means even. Square root of x squared, the answer to be true, absolute value of the x. Because x can be minus. Look here, suppose x is minus 5. Another example here. Suppose x is minus 5. Replace here minus 5 all squared. Now, minus 5 squared in the all, we have bracket here, it's 25. Square root of 25 is 5. This is not x because x is minus 5 given at the beginning. X was minus 5, but the answer here is not x. It is only 5, which means the absolute value of minus 5. Please be careful about this slide. Let's see, we have example 2. 7 small parts. Simplify the radicals. Number 1, square root of p to the power 4. Fourth root of p to the power 4. Fifth root of k to the power 5. See here, the important thing, you have to look at the index first. And then you have to use this property here. If the index is even, put absolute value. If the index is odd, only the number. But you have to have the same power here, same power, you see, as the index. So what is the first one here? Square. See, the index here is 2. So this is absolute value of p squared. Now this is fourth root of p to the power 4. The power is the same as the index. So this is absolute value of p. See, the first one, absolute value of p squared. You can try these other examples here, and then I can show you on the next slide. See, look at number 7, please. Square root of x squared minus 4x plus 4. What is the answer, you think? Can we split these radicals? We cannot split these radicals here. Split square root of x squared, square root of 4x. You cannot split it. You can see that there is one video about errors in radicals. You can check math common errors. Let's see the answers here. Number 1, as I mentioned, we have p squared all to the power 2. So this is absolute value of this, because this 2, the same as this index. So whatever we have inside, p squared. Another way you can say p to the power 4 divided by 2. So it becomes p squared. We know in the absolute value, you can check the video on the absolute value. Absolute value of p squared is equal p squared. That's correct here. Now, fourth root of p to the power 4. We have the same index as the power. So this is absolute value of p. We cannot do there anything because we don't know what is p. So we have to leave it. Now look at here. This is odd. Fifth root of k to the 5. Only k because the index is odd. Square root of minus 8. Not real number. Because, you see, what is the number squared to give us minus 8? Give me a number. Think of any number, real number. When you square it, you get minus 8. No number there. Now, listen here carefully also, number 5. Sixth root of minus 2 to the power 6. This is the absolute value of this number minus 2. So it will be 2. Sixth root of minus 64, not real number, because the index here is even and this is negative. So this is like 4 and 6, same idea. Now this one is little tricky, number 7. We cannot simplify this unless we factor it. We write perfect squared, x minus 2 all squared. So this is like a number here, like p to the power 4. This is like a number squared, and the index is 2. So the answer, absolute value of x minus 2. And that's it. We don't have a condition. We cannot go further. Only absolute value of x minus 2 is the correct answer. Now, try at home. Usually all these try at home extra questions and practice, you can find the complete answers in another video called additional solved questions. Additional solved questions. So this is nice question here, 7th root, 8th root, cube root. And then if you try it yourself, please, if you can get the answer, -4 is the answer. If you need the steps, go to that video, additional solved questions in algebra. Now let's see the rules now. There are 3 important rules, simple, really simple. You can multiply radicals. So we call the first rule here is product. Product means we multiply. Quotient, we divide. And if we have 2 radicals with these indices. So nth root of A times the nth root of B. All right, this is nth root of A times B. So we can multiply. Remember, these are the condition. The roots should exist. So this is a real number, this is a real number, then this is a real number, nth root of AB. When you divide, you can make it in one radical, nth root of A over B. Also B cannot be 0. We call this quotient. If we have nth root of A, so we multiply the indices. So this is index M, index N. When we multiply, we say multiply the indices. Mth root of A. There are many examples here. Let's see the first one. Very nice question. I think it's a good idea here. You can pause the video for a minute and try it yourself and see if you can get the answer. Square root of 6, I will help you here. You can pause it please now. Times square root of 54 over cube root of square root of 64 plus square root of 175 times this one here. So you can split here the radicals. Here you have, there's a formula, the last one here, you can multiply the indices. And here you can split into prime numbers. 54 is 6 times 9. I think you can check now your answer and see if it is correct. The final answer for this question, example number 3, is 16. Anyone get that answer? Okay, let's see. Square root of 6 times square root of 54. We know that will be square root of 6 times 54. Let me tell you here a little advice, please. Do not, especially if you don't have a calculator, do not multiply 6 times 54. Do not. Because you get a big number, then you have to break it down. Leave the 6. 54, we know 6 times 9. So 6 and 6 will be 6 squared. 9 will be 3 squared. Square root of 6 squared is 6. Square root of 3 squared is 3. So that's 18, the answer for the first part. Now, cube root of square root of 64, we multiply the indices. 6th root of 64 is 2. Square root of 175, this is 25 times 7. So square root of 25 is 5, and square root of 7, we leave it. The last part, we split the radicals here, square root of 7 over square root of 25, which is 5. I just put all the numbers, 18 over 2, plus 5 square root of 7 times square root of 7 over 5. We cancel the 5 here. See, 18 over 2 is 9. Square root of 7 is 7. When you add 7 and 9, 16 is the nice answer. So look at this question here. Very big question. And the answer is only 16 without using any calculator. So here is the answer. Now let's see another example 4. Let's simplify the expressions 1, 2, 3. We have here 5th root. So the index here is 5. 4th root, the index is 4. Cube root, the index is 3. So what do we have to do here? We have to break down the numbers inside and see which number we can take out, which number we leave under the radical. See, like 32. Well, 32 is a very famous number in math. 32 is 2 to the power 5. Easy number, 32. Always 2 to the power 5. So we can take 2 out. D to the power 5. See the index here, even or odd. You have to remember, even or odd, this is odd. So we can take D out. See, that's the first one. I did the first one for you. So 2 is out, D is out, no absolute value, nothing. Here you have to put absolute value. 4th root of 81. What number to the power 4 will give us 81 or close to 81? Try to think. And this is cube root, same number 81. You see cube. What number will make it cube close to 81? So try to practice, please, and then let's see the answers. So the first one, minus 3 from the question. 2 is coming from 2 power 5. D power 5 is only D. See the whole answer, minus 6D. That's it. First part, minus 6D. Now let's see the second one. 81, 3 power 4. See, I wrote here 81, 3 power 4. See, this is the same 81, but I wrote it 27 times 3. You see why? It is the same, 3 power 4. Because here we have the index 3, here we have the index 4. So I need something power 4. So 3 is the answer outside. A to the power 8, I can make it a squared all to the power 4. So I put absolute value of a squared and also absolute value of b. But I know from the absolute value video, you can check the absolute value videos, the absolute value of a squared is the same as a squared. It's a positive number. So the final answer here for number 2, 3 a squared absolute value of b. Now the last one, little tricky, cube root. So I need a number to the power 3. So I can think of 27 because 27 is 3 cubed. So I take 3 out. But remember, I have to leave 1 3 because in the 81, I have 3 to the power 4. X power 5, I need x cubed. So I have to leave x squared. Y to the power 7, I can take y power 6, which is y squared, y squared, y squared, and then I leave 1y inside the cube root. That's a little tricky answer there. Now, another try at home, 2. Simplify 6th root of 0.000064 times x to the power 7. This is times x to the power 7. I think the answer is there. Absolute value of x, 6th root of x over 5. If you need the detailed solution, you can go and see additional solved questions on radicals. Like radicals. So we have seen before in math, like terms, like radicals. What are like radicals? Radicals that are similar or like, we can add them or subtract them. So what are the conditions on these like radicals? It's very clear written here. Same index, same radicand. You know these words from the first slide. Same index, we should have the same index and we should have the same radicand at the same time. So 7 square root of 3 and 4 square root of 3, these are like radicals. When we say like radicals, that means we can add them, we can subtract them, and always we can multiply them and divide them. Let's see, like here, 5 square root of 2, 5 square root of 3. Are these radicals like? No, not like. Let's see, adding and subtracting radicals. Like radicals can be added and subtracted. This is the same idea on the previous slide. 8 square root of 3, 6 square root of 3. Can we add? You have to answer yes or no. Yes, because they are like. So what do? We can just add the numbers 8 and 6, or simply take the square root of 3, common factor, and then add inside. So this is 14. See, this is the same way you can add 8x plus 6x. You see, you know that? 8x plus 6x, 14x. Now, 2 square root of 11 minus 7 square root of 10 cannot subtract. Why? What is the reason? Not the same radicand. This one we can add because we have the same index 4, 4. 10 PQ, 10 PQ is the same. 3 minus 7 is minus 4. That's the answer. 4th root of 10 PQ. Another example, 5. Can we subtract the first one, please? Square root of 50 minus square root of 18. Somebody might say we cannot. Yes, we cannot, like this, we cannot. But what can we do to try, if we can? Let me help you in the first one. Square root of 50. How can we break it down into prime numbers? Square root of 50. Maybe what? 25 times 2. And square root of 18. This is 9 times 2. Let me show you the first one. Square root of 50, I can write 25 times 2. Square root of 18, I will write 9 times 2. This will be 5 out. Square root of 25 is 5. Square root of 2 minus 3 out from the 9. See, this is the same radical, same radicand, same index. 5 minus 3, the answer is 2 square root of 2. Nice question here. Square root of 50, you see square root of 50 minus square root of 18, the answer 2 square root of 2. Can you try number 2, please? And then we try number 3. For sure, the idea here is to simplify each term, each radical, and then see if you can add. Maybe we simplify it and we cannot add. Maybe. Okay. I think now you have finished number 2. Let's see number 2. Number 2, the answer is 19x square root of 2xy. If you get this answer, then you are good. So 98, what is 98? See, the index here is 2, so I try to think of 98 as 49 times 2, because I need something squared, so 7 squared. 32, I can break it down into 16 times 2. Square root of 16 is 4, and I have 3x from the beginning, from the question, you see, 3x. 3x times 4, 12x. And now inside the radical, I have 2xy, 2xy. See the cube here, x cubed, I break it down into x squared and x. So I take x out. So 7x, 3xy, that will be 12, 19x square root of 2xy. This is number 3, same idea, you can read it. See the answer here, the same cube root of mn squared, take it common factor, because we cannot add these two. 4mn plus 3m to the power 3 n to the power 4, these are unlike terms, so we cannot add them. We just leave it like this. Leave it all in the bracket, cube root of mn squared. Now, another try at home number 3, same idea as this one, as example 5. The answer is minus 14 x cubed y cubed, cube root of 2y. If you need the detailed solution, please go to additional solved questions in algebra. Now, this topic is to be continued in lecture 8. So this is lecture 7, and we will continue this one in lecture 8. So altogether will be the same topic. Thank you for watching this video. I hope I can see you in another video with another topic. So this is lecture 7, just to remind you, in algebra course. Thank you very much.